This is lesson 8 on calculus, and we are now starting with the equation of a tangent line. In the graph, we are given the function of fx, which in this case is a parabola. And what I've drawn in is a tangent to the parabola. What we have learned in previous lessons are that the gradient of the tangent line can be determined by the first derivative of fx. In grade 11, we used the following formula to find the equation of the line. That was y minus y1 equals to the gradient times x minus x1, where x1 and y1 was a coordinate or point on the tangent line. So in today's lesson, we would learn how to find the equation of this tangent line at any point of x. In our first example, we want to determine the equation of the tangent to fx, where fx is equal to 3x squared minus 6x minus 5 at x is equal to 2. So what we want to determine is the equation of a tangent line. And we are going to use this format, which we have learned in grade 11. Remember, you also have another format, y is equal to mx plus c. And you are welcome to use this as well. So what we need to find is the gradient, a point x1 and y1 to substitute, and then we can simplify. So x1 is given because the question says determine the equation of the tangent to fx at x equal to 2. So we know we want to find the equation of the tangent line where this value is equal to 2. Now we can find y1 by substituting 2 into fx. You don't have to show the substitution. You can simply write f2 and then equal to negative 5. Most students can do this mentally, or they use a calculator to simplify the calculation and also to save time. So now we have x1 and y1, and we only need the gradient. In the previous lessons we learned that the first derivative of fx is an equation for the gradient. So if I take the first derivative, so 3x squared, and if I differentiate, I find that is 6x, and negative 6x will differentiate to negative 6, and the negative 5 will fall away. We discussed how to differentiate in the previous lesson. Now I have a formula for the gradient. And we want to find the gradient where x is equal to 2. So I'll substitute 2 into this equation for the gradient. Therefore, the gradient of the tangent line where x is equal to 2 is equal to 6. Now we have y1, the gradient, x1, to substitute into the equation to find the tangent line to fx at x equal to 2. So I simply substitute my y1 value of negative 5, my gradient value of 6, and the x value of 2. And when I simplify it, I find that the equation of the tangent at x is equals to 2 is 6x minus 17. Now we are moving on to a slightly different example. We are going to use the same theory, but it's just presented differently. We are given the following information. A tangent to the graph fx equal to negative 2x squared plus 7x minus 4 has a gradient of 7. Determine the point of contact with the graph, and secondly, find the equation of the tangent. In order to determine the point of contact with fx, we need to find x1 and y1 on the straight line. And remember, the straight line formula is y minus y1 equals to the gradient times x minus x1. In the information, we are given that the gradient is equal to 7. And from previous lessons, we also know that the equation of the gradient is the derivative of fx. The derivative of fx is negative 4x plus 7. So that gradient is equal to 7, and therefore I can solve x, which is 0. So the gradient of the tangent line would be equal to 7, where x is equal to 0. Therefore, my x1 value is 0. Now that I have an x value, I can find the y value by substituting the value of x into the original formula of fx. Notice I'm substituting into the original fx and not the derivative. The derivative only represents the gradient. So to find a y value, I need to substitute into the full formula of fx, where fx is negative 2x squared plus 7x minus 4. So I replace x with 0, and therefore I find the y value is negative 4. Therefore, the point of contact with fx, where the gradient is equal to 7, is 0 and negative 4. The second question was to find the equation of the tangent line. In the previous question, we have found y1 and we have found x1, and we are given the gradient is equal to 7. So I simply substitute and simplify, and the equation of the tangent is y equal to 7x minus 4. Let's move on to our third example. Determine the equation of the tangent or tangents to fx if the tangents are parallel to the line y equals to 5x plus 1. Now, if you remember from previous grades, when lines are parallel, their gradients are the same. And when lines are perpendicular, their gradients produce a product of negative 1. In order to determine the equation of the tangent or tangents, we need to use this gradient value. Let us start with the equation of a line, which is given as y minus y1 is equal to the gradient times x minus x1. The gradient is equal to 5 because parallel lines have equal gradients. Now we need to determine the x values where the gradient would be equal to 5. So we have fx is equals to 2x cubed plus a half x squared minus 10x. And I find the first derivative. So it's 3 times 2, which is 6x squared, plus, so 2 in the exponent times a half, subtracting 1 from the exponent. If I differentiate, that becomes x. And negative 10x, when differentiated, becomes negative 10. We know that the gradient is equal to 5. Remember, the derivative represents the gradient, so the gradient is equal to 5. And now I write it in standard form by moving the 5 over. Next, we need to factorize. Remember, if you can't factorize or you're not comfortable with factorizing, you can still solve x using the quadratic formula. Now I have two values of x. So 2x minus 3 equal to 0 and 3x plus 5 equal to 0. And because we have two separate values of x, we would find two different equations of the tangent. So we'll have two tangent lines with a gradient of 5. The one tangent line would be at x equals to 3 over 2, and the second tangent line would be at x equals to negative 5 over 3. These then represent x1 in both of our formulas. And to find y1, I need to substitute x, 3 over 2, into the original fx, and x equals to negative 5 over 3 into the original fx value. Now I have two values of y1. So it's x1s and y1s. We already know that the gradient is equal to 5. You don't have to do it simultaneously as I'm doing it. You can first work with the one value and then work with the other value. So simply in this step, what I'm doing is I'm substituting the values of y1 into the equation of a tangent line and x1s into the equation of the tangent and the gradient of 5. Our final step then is to simplify. Therefore, for the function of fx, I have two tangent lines that have a gradient of 5x.